So picking back up, remember that our goal here is to solve the polynomials. And to solve the polynomials, we therefore have to factor the polynomials. But if you take a look at this first one right here, I notice 2x to the fourth, 26x squared, and 28. I can just divide a 2. Now, technically I'm factoring that out, but it's not going to affect the solution just because dividing by 2, factoring out a 2. Remember, all I care about now is x. So if I take out a 2, I'm going to get x to the fourth minus 13x squared minus 14 equals 0 divided by 2 is 0. And because there's 3 terms, I'm going to set up my x. I can still factor by grouping. I just have to split up that middle term first. So sum to negative 13, product is negative 14. I'm going to give you a minute to think about them. Hopefully you got negative 14 and 1. Now, if you go to break up your middle term, remember that negative 13x squared is going to become negative 14x squared plus 1x squared. But because it's a trinomial and a equals 1, I can do the shortcut on this. But it's going to be x squared minus 14 times x squared plus 1 equals 0. Now I got the negative 14 and the 1 from over here when I set up my x because a was 1. X squared because it was x to the fourth power. So when it splits up, it becomes x squared and x squared. Just like x squared splits up into x and x, x to the fourth is going to be a little bit different. And now that I have this factored, now I can solve. So x squared minus 14 could equal 0. Or x squared plus 1 could equal 0. And when I go to solve, I add 14, so I get x squared equals 14, square root it. And remember, x squared means 2 solutions. So x is actually going to be plus or minus the square root of 14. Over here, subtract 1, x squared equals negative 1, square root it, square root it. Well, the square root of negative 1 is just I, that imaginary number, but remember, plus or minus, because I'm doing the square root of it, so plus or minus I. So in this polynomial, I have 2 real solutions and 2 imaginary solutions. So I have plus or minus the square root of 14, which nothing can take out, 7 and 2. There's no perfect pairs in there at all. And then I have plus or minus I. So 2 real solutions, 2 imaginary solutions, but because there's 4 total solutions, each one would have a multiplicity of 1. That's it. Now, you can plug these in to check it. The square root of negative 1 when you plug in is going to be a little bit more complicated because you have to remember that 2 times the square root of negative 1 squared, that just becomes positive 1. So you get 2 minus 26i squared. Remember, that changes that to a plus, minus 28. Well, what's 2 plus 26? 28. What's 28 minus 28? 0. It works. So you could still check them, all of these, but it just gets a little bit more complicated because the solutions are a little bit more complicated. So taking a look at this next one, 5x to the fourth plus 50x squared plus 80. I can take out a 5. Nothing else. If there were x, if it were like x cubed, x squared, x, I could do more. But in this case, I'm just going to divide everything by 5 and take that out to reduce my numbers when I'm solving. So I get x to the fourth plus 10x squared plus 16 equals 0. Trinomial, so set up your x. So sum to 10, product is 16. If it's a trinomial, you're going to have to make the x so you can group it up. If there's 4 terms, you can just group it as is. If there's 2 terms, it's a special one. So just make sure you keep those separated. And what multiplies to give you 16 but adds to give you 10? 8 and 2. So it's just like the last one where a is 1. So I'm going to break that up into x squared plus 8 and x squared plus 2 equals 0. So when you go to solve, you get x squared plus 8 equals 0, and I get x squared plus 2 equals 0. So x squared minus, if I subtract the 8, I get x squared equals negative 8. Square root, x could be plus or minus the square root of negative 8. But I have to clean that up. So I'm going to have to take out an I, but remember 8 is 4 times 2, and 4 is 2 times 2. So I'm going to take out a 2. Because it's negative, I'm taking out an I. So I'm going to get plus or minus 2I root 2. Over here, subtract the 2. Square root, square root. So you get plus or minus the square root of negative 2. Well, take out an I, and the square root of 2 is just the square root of 2. So in this case, I have 4 imaginary solutions. I have plus or minus 2I root 2, and I have plus or minus I root 2. But because there's 4 of them, and remember I need it to add up to 4, the multiplicity of each one is 1. So I can just write multiplicity of each is 1. Because each one, there's 4 of them, so each one has a multiplicity of 1. Okay, moving on, if I have one like this, I have 27x cubed equals 343. Remember, if we're solving by factoring, it needs to equal 0. So my first step is I'm going to subtract the 343. So 27x cubed minus 343 equals 0. If you try to divide by 27, 343 divided by 27 gives you a decimal, which remember, you can't have that. So there's nothing that I can take out, but hopefully something is going off in your head. 27, 343. This is a difference of cubes. And remember, difference of cubes was SOAP. You're going to have a linear factor and you're going to have a quadratic factor. So to get the linear factor, you just cube root, cube root. So the cube root of 27x cubed would be 3x. Remember, you have 5 blanks to fill in. 2 here, 3 here. You can come in, I'm just filming a video. So 2 here, 3 here. So cubic root of 27x cubed is 3x. The cubic root of 343 is 7. And then to go from linear to quadratic, remember you just square it. Yeah, you could borrow the testing folders.
Do you remember this from Schitt's Creek?
No. Oh. You just said it in my video. Guys, I'm not refilming. I'm really sorry. Anyways, 3x squared is 9x squared. To get the last term, 7 squared is 49. And then remember, to get the middle term, we multiply. So 3x times 7 is 21x. And then SOAP to get your signs. So same sign would be minus, opposite sign would be a plus, and always positive would be a plus. Okay, but remember, the goal wasn't to factor here. The goal was to actually solve it. So now I have 2 different equations to solve. I have a linear and a quadratic. So when I solve the linear, 3x minus 7 could equal 0. Add 7, so I get 3x equals 7. Divide both sides by 3. So x is 7/3. You can have fractions as answers. When I go to solve this one, I'm going to warn you right now. Any difference of cubes or sum of cubes, your quadratic is not going to factor. And you're going to have to solve that by quadratic formula, completing the square, something different. So if you have a difference of cubes or a sum of cubes, that quadratic is going to end up giving you imaginary solutions 99% of the time. It's not going to work out nice and neat. So if you have a difference of cubes, sum of cubes with quadratic, just jump straight into quadratic formula. So that's what I'm going to do here. I have a quadratic. I just warned you it's going to be messy, so jump in with quadratic formula. So hopefully you're singing the song. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So 2 times a is 9. And you're going to get some crazy big numbers, and that's okay. So we know that 2 times 9 is 18. But then I have to go through and find out what's underneath that radical. So if you just type in 21 squared minus 4 times 9, I'm doing it right now, times 49 into the calculator, you're going to get negative 1,323. So I'm going to clean this up clean it up, not much to clean. Negative 21 plus or minus the square root of negative 1,323 all over 18. Okay, now I need to find out if I can break down and make a factor tree with 1,323. Now, we know we're going to take out an I because it's negative, but ask yourself, does 3 go into it? And the answer is yes. 3 goes into it and you get 441. If I divide 441 by 3, I get 3 and 147. And 147 can be divided by 3, so I get 3 and 49. And 49 breaks down into 7 and 7. So because of all the 3's I divided by 3, I end up with a pair of 3's, and I get a pair of 7's. So what I'm going to take out is 3 times 7, which is 21. So I have the 21 out front, but now I'm going to take out a 21. Because it was negative, I'm taking out 21i. Remember, 3 times 3, or 3 times 7, because I had 2 3's, 2 7's. But then what's left underneath? I have this solo 3 that didn't have a partner. Square root of 3 all over 18. Now I'm going to erase this factor tree so I have more room. Remember, you can just pause it if you want to catch it. But now that you're here, remember you have to ask yourself, can anything be simplified out of these parts? And 3 goes into all of those. So my first answer way back over here was 7/3. But once I clean that up, take out the 3's, I'm going to get -7 plus or minus 7i root 3 all over 18 divided by 3 is 6. And that's it. Some take longer than others. So taking a look at the next one, the issue I have with this one is that it's factored but not quite in the form that I need it to be. I need it to equal 0. So I'm going to distribute everything out, put it in standard form, make sure that it equals 0. So I get x cubed plus 8x equals 8x plus 1. So I'm going to subtract 8x, subtract 8x, subtract the 1, subtract the 1. That cancels, and I end up with x cubed minus 1 equals 0. Which hopefully something's going off in your head. Ding, ding, ding. This is a difference of cubes. So I'm going to follow the SOAP thing again. Remember, 2 terms and then 3 terms. So my 2 terms would be cubic root, cubic root. So I get x minus 1. Remember, SOAP, same sign. My quadratic is going to be x squared. The last term would be 1. X times 1 is x, and then plus. From my SOAP, same sign, opposite sign, always positive. And now that I'm here, now I have to solve. So it adds up, equals 0. The first one, I add the 1. So x is 1. And then how are you going to solve this quadratic? If it's a sum of cubes or difference of cubes, solve the quadratic with quadratic formula. So x equals negative b would be -1 plus or minus the square root of b squared is 1 squared minus 4 times a times c. All over 2 times a is 1. So 4 times 1 times 1 is 4. 1 minus 4 is -3. 2 times 1 is 2. So I get -1 plus or minus the square root of -3 over 2. Now 3 has no perfect pairs in it, but because it's -3, I need to take out an I. So I get, for my first solution, 1. And then for my next solution, -1 plus or minus I root 3 all over 2. And notice that this was a difference of cubes when we had 3 answers, 1 here. The quadratic gave us 2, so 3 solutions. Over here, I have 1 for my linear, 2 for my quadratic. 1 plus 2 makes 3. So I know that I'm on the right path. So I did it correctly. Now, I know this video is long. It's into 4 parts. I'm going to take some time in the next one to talk about how are the zeros related to the graph of a polynomial. And it goes back to zeros mean roots and x-intercepts. So we're going to dive into that in the next video. What do you do when it's a graph, or how do you graph polynomials?